Hello, my name is Rohan Kumar Bhowmick from EC third year CGs. My today's topic is pulse code modulation. Let's start. At first, we have to understand the block diagram of pulse code modulation or PCM. Here, an analog signal is going to PCM encoder for sampling to be a PAM signal or pulse amplitude modulated signal. Then it goes to a quantizer that quantize the signal into quantized signal. Then it going to an encoder that encodes the quantized signal into digital data. Now, quantization. Quantization is the process of rounding off the sample value to the nearest quantization level. Remember that the number of quantization levels is predefined. Let us understand with an example mentioning the steps. At step 1, total voltage range is divided into q equal intervals of step size s. Here, step size or q is predefined 4. We can see that in step 1, the calculation is set on 4. In step 2, we draw the midlines representing quantization levels. We can see that here step 2 is done. At step 3, we assign binary codes which is predefined to each quantization level. We can see that here the sample values is 0.4 and 0.784. Here comes the final step. It is to calculate quantization error. Represent each quantization level with predefined binary codes. You can see that clearly. Now coming to the bandwidth of PCM system is primarily determined by its bit rate and pulse shaping. Bit rate, the number of bits transmitted per second, is called bit rate, and pulse shaping is the mathematical function applied to the digital signal to limit its bandwidth. Now, bandwidth calculation. A rough estimate of minimum bandwidth requires for PCM system can be calculated as bandwidth is greater than equal to half of its bit rate or represented as R. This approximation assumes a rectangular pulse shape which is not practical in real world system due to its infinite bandwidth. Signal to quantization noise ratio or SQNR is a crucial metric in evaluating the quality of PCM system. It measures the ratio of the power of the original signal to the power of quantization or quantize noise introduced during the analog to digital conversion process. A higher SQNR indicates better signal quality, as it means the quantization noise is relatively low compared to the signal. Here we can see that the signal to noise ratio in decibel is 10 into log S by N, where S represents signal power and N represents noise power. Thank you.